As we are speaking about waves, we know by now that we have fixed waves where we have each wave is having a fixed wavelength and a fixed form. When you have waves, let's say wave A and wave B, moving towards each other, they have a point, what we call the point of interference. That's the actual position of the medium at area where waves overlap. They construct an interference that we call it constructive interference. That interference will cause a little bit of undetermined wave or an oscillation in the wave where both waves will blend together. Eventually, they will generate two final waves different than the two initial waves before interference. Those two final waves will have a certain shape, and that shape is called a fixed shape. So we have here the purple wave representing, let's say, wave B, and the blue wave is representing wave A. And if you look at the red, that would be representing wave A plus wave B. So in this case, we have constructed a fixed wave by interfering two well-defined waves. Second type of waves is the standing waves. A standing wave is a condition in a spring or other medium in which a wave seems to oscillate around stationary point called a node. The wavelength of the standing wave is the distance between the alternate node or the alternate antinode. What does that mean? When we say a standing wave, you have, of course, a wave being oscillating up and down around the equilibrium point. You have another wave oscillating around full reverse of the first wave. Now, the point where the wave intersects with the equilibrium line and the point where it intersects as well with the other wave is called a node, and that node will remain motionless. It's like as if the waves are having a joint over here and they swing and oscillate around it. And we can realize here there is, this is the fixed right hand side fixed point for the wave, and this is the left hand side fixed point for the wave. And each cross section is called a node. So we have a node here, a node here, a node here, a node here, and here, and here. So we can call those points as, you can imagine them as a mechanical joint. Imagine you have a rope and you're swinging it up and down, but you bring your friend, you let the rope attach to a wall, but you bring your friend and hold the rope at a certain point and you keep swinging, then, the rope will keep giving a certain oscillation, but will be fixed at that point. Even though physically it's not fixed, but, the wave or the two waves are intersecting at that point all the time of that wave oscillation or wavelength. So we can define the node as the point on a spring or other medium at which only destructive interference occur, a point that never vibrate between maximum positive amplitude and a maximum negative amplitude. And the standing wave node occur at an interval of 1 over 2 of the wavelength, or 1 over 2 lambda. There's something else called the antinode. Antinode is the point in the interference, like here, a point in an interference pattern that oscillate with the maximum amplitude, and we can define that standing wave antinodes occur at an interval of 1 over 2 lambda, or at half of the wavelength of that wave.